Okay, so this titration is to determine the water crystallization of hydrated sodium carbonate. So in other words, it's to find out the value of X in that formula. Yeah, it's to find out how many molecules of water per per unit of sodium carbonate. Okay, so we read the question and we've got 4.39 grams of the sodium carbonate in a volumetric flask. So let's draw that as usual. It's a terrible volumetric flask, that one is all lopsided, never mind. We've got 4.39 grams of sodium carbonate in there, hydrated sodium carbonate. And the hydrated bit makes all the difference, of course, because there's quite a lot of water in that 4.39 grams. Okay, and as usual, we are going to take out 25 centimeters cubed of that, put it into a conical flask. So take a tenth of it out. Okay, so that's going to go in there. And that is going to be titrated against HCl of concentration and that volume there. Okay, so we draw a burette. And if we just put in there, what is it? It is 0.125 HCl, 0.125 moles per decimeter cubed. And the volume is 21.8 centimeters cubed. Okay. And let's look at our equation. We should be getting familiar with this equation now. Look, it's 1 mole of the sodium carbonate reacts with 2 moles of the hydrochloric acid. Okay, so what can we work out? Let's put our equations up here as usual. Concentration is equal to moles over volume in dm cubed, and moles is equal to mass over mR, or second equation. Okay, so we normally have to find out the moles or something, don't we? Even if we can't see exactly where we're going. So can we work out the moles of sodium carbonate? Well, we know the mass, but we can't work out the number of moles because we don't know the MR, because we don't know what that X is there, so we can't work out the MR of hydrated sodium carbonate. So that's not going to be the way forward. Let's have a look at the hydrochloric acid here. This looks more promising because we know the concentration and we know the volume. Okay, so let's write down that. Moles of HCl, conc times volume. So that's 0.125 multiplied by 21.8 centimeters cubed is 0.0218 dm cubed. And that's going to be 2.725 times 10 to the minus 3 moles. Okay, now it's a 1 to 2 ratio, so our moles of sodium carbonate is going to be half of that. So moles of sodium carbonate in 25 centimeters cubed is going to be equal to 2.725 times 10 to the minus 3 over 2, which is equal to 1.36 times 10 to the minus 3 moles. Okay, so therefore, that's only in 25, but we've got to do it into 250. It's a 10, so times it by 10. So moles sodium carbonate in 250. That's going to be 10 times that, so that's 1.363 times 10 to the minus 2 moles. Now, what we do know now is we know the moles of sodium carbonate in 250, and we also know the mass of that in 250. So if we use this equation here, we can work out what the MR of the hydrated sodium carbonate is, and when we've done that, we can work out what the value of X should be. So let's work out the MR first of all. So MR of the sodium carbonate hydrated is, if you rearrange that, it's mass over moles. So the mass we have is 4.39, and the number of moles is 1.363 times 10 to the minus 2. So 4.39 divided by gives us a 322.2 is the MR. Okay, so now we have to look at our formula of sodium, hydrated sodium carbonate. We have to find out what the value of X is. So this bit, you know, the total MR is equal to 322.2. This bit here is 2 times 23 for sodium, plus 12 for carbon, plus 3 times 60, and that's 106. So that means that this bit here is going to be equal to 322.2 minus 106, which is equal to 216. Okay, so how many water molecules make up an MR of 216? So we know one more molecule is 18, so X is going to be equal to 216 divided by 18, the MR of one water molecule. And if we do that, it gives us a value of 12.01. Now we know that X can only be whole numbers, so we know that the value of X is 12. So our formula, the final conclusion, is sodium carbonate dot 12 H2O. That's quite a lot of water molecules for water crystallization. I don't think there's many higher than that. Okay, so that is the answer to that.